Hello, my name is Kate Levinson, and today I will be discussing the developmental network and the effect mutations has on the outcome. So here we can see our hypothetical developmental network. The pathway leads to the development of spikes in certain cells of the ectoderm of the spiny beetle. However, not all cells in the ectoderm have spikes. Some are smooth. Let's go over what we have. The S gene is represented by a cat, which activates the P gene, represented by a doll. The doll activates the I gene, represented by a turtle. The I gene inhibits the K gene, represented by a flower. The K gene inhibits the E gene, which is represented by a rainbow. Finally, the E gene activates the formation of spikes. Now we can see how different mutations will affect the formation of spikes in the ectoderm of the spiny beetle. The first mutation we will discuss is the P gene. In this scenario, the P gene is mutated and the doll is taken away from the pathway. With the doll absent, the turtle is not able to be activated, which then results in the daisy not being inhibited. When the daisy is present, it inhibits the rainbow, which then can't produce the spikes. So with this mutation, spikes are not developed. The second mutation we will discuss is the I gene. In this scenario, the I gene is mutated and the turtle is taken away from the pathway. With the turtle absent, the daisy is not inhibited, so therefore it will be expressed. When the daisy is present, it inhibits the rainbow, which then can't produce the spikes. So with this mutation, spikes are not developed. The third mutation we will discuss is a double mutation of the I and E genes. In this scenario, the I and E gene are mutated, and the turtle and rainbow are taken away from the pathway. With the turtle and rainbow absent, the spikes are not developed. This is because in every pathway, the rainbow is the final gene, so simply taking away the rainbow will not produce spikes. So there is no turtle to inhibit the daisy and no rainbow to activate the spikes, so no spikes are produced. The final mutation we have is a double mutation of the S and K genes. In this scenario, the S and the K gene are mutated, so the cat and daisy are taken away from the pathway. With the cat absent, the doll is not activated, which then can't activate the turtle. If the turtle isn't activated, it won't inhibit the daisy, but since the daisy is mutated, that is okay. Since the daisy is mutated, it can't inhibit the rainbow, and therefore the rainbow can activate spikes. So with this mutation, spikes are developed. Not all cells in the ectoderm will have spikes, because it is not always beneficial to have them all over the ectoderm. The spikes can be advantageous for protection against predators, but in places like the stomach, there is no need for spikes because they are not being attacked from the bottom and may prohibit movement.